Today we are in Today we're in chapter 8, section 2. And that section is adding and subtracting rational expressions. Adding and subtracting rational expressions. So the first problem I've got up there, 3 over 7 plus 2 over 7. Hopefully that is something that we don't have to really talk about what happens. What do we get? 5 over 7. The biggie there, of course, is that the denominators are the same. They don't change, right? We only add the tops. So just kind of remembering that when we add with fractions, only the top changes, the denominator stays the same. So the numerator remains the same. All right, now let's talk about 5 over 6 plus 4 over 9. Can I add those together? No. Why? They're not the same. The denominators are not the same. What do we have to do? Find the least common denominator, which is also known as LCM, and the M stands for multiple, the least common multiple, right? Okay, now, before you go writing stuff down and actually doing this problem, right, I want to talk about it for just a hot second, and then we're going to do something a little bit new. I know that the least common denominator between 6 and 9 is 18. And then, of course, you're going to have to multiply this side by 2. And so you're multiplying that side by 2. And then over here, you're multiplying this side by 3. And then whatever you do to the bottom, you have to do to the top, right? Okay. So we're going to do this in a slightly different way today, but only to illustrate a point. Not because I'm saying every time you find a common denominator, you have to do it this way. Okay? I will use this method later, but when there are numbers, you can just do the same thing you've always done. But I want to make this kind of clear where it's nice and easy with numbers. So, can someone give me the prime factorization of 6? What is the prime factorization of 6? Yes? 3 times 2. Prime factorization, for those of you that don't remember, is a list of all prime numbers that will multiply together to give me what I started with. What is the prime factorization of 9? Yeah. 3 times 3. Okay. So now that I have these prime factorizations, our new method, this thing that we will do a little bit later, is simply looking at the factors and figuring out what's missing from each side. So, looking at 6, right? 6 has a 3. Does 9 have a 3? Okay, we're good. 6 has a 2. Does 9 have a 2? No. So it's going to need a 2. And so I will make sure that I come over here and I multiply this side by a 2 and a 2, right? And that 2 came from right there. Right? So now I go over to the 9, and we've already established that they both have a 3, so we're good, right? But 9 has a second 3, an extra 3. So does this one have a extra 3? No. So it needs a 3. And so I'm going to take this 3 and multiply both sides, or top and bottom, by 3. Now, of course, we already knew that we were going to have to multiply by 3 and multiply by 2. We talked about that. But I wanted you to see that we can also look at the factors and figure out what my least common multiple will be and what I need to multiply both sides by as well. Yes?
Why is it 3 over 3, not 3 over 1?
If I make it 3 over 1, then I've changed the top without changing the bottom, and now I have a new fraction. Right? My goal is that I'm not changing the value of the fraction. 3 over 1 is 3, but 3 over 3 is 1. And multiplying by 1 is legit and fine. Yeah?
How would you decide which number to use? Like for the first half, 3 times 2, like how do you decide it's the 2 and not the 3?
I'm not quite following.
Like, for 5/6,
Yes.
times 2, how would you decide it's the 2 and not the 3 that you multiply?
Well, so what I do is I look at I just chose the 3 first because it was first. I could have chosen the 2 first if it was written first. It doesn't matter, right? But I'm looking, this has a 3 in this group of factors. Do I have a 3 in this group of factors? Yes. So I don't need to multiply this one by a 3. It has a 3, right? Does that make sense? But when I look at the 2, this group of factors does not have a 2. If I'm going to make these two things the same, then if this one has a 2, then this one must also have a 2. And so I need to multiply the bottom by a 2 in order for it to match. Does that make a little bit of sense? So, and then once I've taken care of the first one, now I've got to come over here and take a look at the second one. We've already established that this 3 and this 3 are good, but this one has an extra 3, and this one does not. And so now I have to add another 3. Does that make sense? I'm trying to make the list of factors be exactly the same. So, all right, now, of course, if we finish this off, we already know that we are going to wind up with 15 over 18, and then we're going to add 8 over 18, which will give me my final answer of 23 over 18. Okay. Now, again, when you come across a new problem, and that new problem has numbers in the denominator, I'm not saying you have to go through this process in order to find the common denominator. Okay? Most of you are smart enough to figure out common denominators for numbers without having to run through this process, right? But we will use this concept soon. All right. Are we good here? All right. So let's try a new problem. Let's do 3y divided by 2x cubed. And then we're going to add 5z over 8x y squared. Okay, so again, I'm going to kind of run through my denominators, and I need to figure out what's missing and what needs to be added to each denominator. So, the first denominator, 2x cubed, it's got a 2. That's a number. Does the second denominator have a number? Yes. Is it the same? No. What is the least common denominator between 2 and 8? 8. What has to happen to the 2 to make that happen?
Multiply by 4.
Multiply by 4. So I know already that one of the things that I'm going to have to do is multiply this side by at least a 4 and a 4. So far, so good? Yes. Okay. Now, the x cubed. Does the other denominator have an x? Yes. Is it the same x? No. What needs to happen to the 8xy squared so that the x's are the same? Multiply by x squared. So I know that I've got to come over here and multiply by x squared on top and bottom so that this x cubed and this x will wind up becoming the same thing. Does that make sense so far? Okay. There's nothing else on the 2x cubed denominator, so now I go over to the 8xy squared. We've taken care of the 8, right? We've taken care of the x. It's got a y squared. Does 2x cubed have a y squared? No. So what do I got to do? Multiply by y squared. And so I need to multiply this by y squared over y squared. Does that make sense? Yes. Okay. So now we multiply and then start to combine. Now I realize that my next step is a step that most of you will probably start skipping, right? Most of you will probably just start kind of combining things in your head as you multiply. Or at the bare minimum, you're not going to write the two equations separately. But for our notes, we're going to write them separately before we combine them. Right? So, here we go. when we multiply here, 4y squared times 3y is going to be 12y to the third power. And my denominator is 8x cubed y squared. So far, so good? All right. Then I have my addition sign. Then we have 5z times x squared, which is going to give me 5x squared z. And my denominator again, 8x cubed y squared. All right. What do I get when I add these two things together? Well, I don't quite get that. It is going to look at least vaguely different than this. Yes?
Just 12y cubed plus 5x squared z all over 8x cubed y squared.
Very good. All right? They don't simplify any further than that. Bless you, by the way. Yeah.
What happens if they can, like, if the top can, like, simplify?
Then if you can physically add the top to the top, then you should do so, right? But if you can't, then it just gets written apart like this. All right. So far, so good. Okay, that's a 2 down here, by the way. There we go. All right, let's try something a little bit different. Yeah.
Wait, can we not do like getting rid of like the y?
Nope,
Oh wait, because it's alright.
because of that addition sign.
Yeah.
All right.
Addition signs.
I know, they're pesky. Let's try this one. So here we have 5 over 6x minus 18 minus x minus 1 over 4x squared minus 14x plus 6. Now here is where factoring comes into play, right? Before I can figure out what's missing from each side, I have to have all my factors. So, can I do anything with 6x minus 18? Will that factor? What does it factor into? 6 times the quantity x minus 3. You are correct. What about my second denominator? What's the first thing I can do?
Do the full thing, just the first thing.
The first thing.
I equal to 2.
Pull out a 2, right? The whole thing is divisible by 2. So I'm going to factor out a 2. That leaves me with 2x squared minus 7x and plus 3. Does that factor?
Yes.
Yes, it does. What does it factor into? Caitlin?
2x squared minus 4x times the quantity of negative 3x plus 6.
Say that one more time.
2x squared minus 4x times the quantity of negative 3x plus 6.
That's not, I hope, your final answer. I hope that's your middle step.
Yeah, I don't know. I'm confused. Wait, no, I'm not. Yeah.
No.
Yes. Wait.
No, this turns into 2x minus 1 and x minus 3.
Oh.
So, I used guess and check, I'll walk through that just real quick, and then we'll go through like the magic bean thing, right? But for guess and check, you write down what it's going to take here and here to get this term. That's pretty easy because it's 2x squared, right? So one of them has to be a 2x, one of them has to be an x. Does that make sense? Okay, so then the other side is that whatever goes in the at the end here and here has to be able to multiply together to get me this. Okay, and so it has to be a 1 and it has to be a 3. And because this middle piece is negative, I know that they both wind up having to be negative because this is positive. Right? A negative and a negative give me a positive. Right? Okay. So now what I got to figure out is, does the 3 go back here or does it go back here? And that's the guess, that's the check part, right? So if I had put the 3 here, I'm pointing at this like you're going to be able to see that later on, right? So if you had put the 3 over here, then and the 1 over here, then you would have taken the 2 times 1 and gotten a 2x, negative 2x. You would have taken negative 3 times x and gotten negative 3. And when you add those together, you would get negative 5, which is not what's here, right? So if I put the negative 3 here, then I do 2 times 3 and get negative 6, and the 1 and the x to get negative 1, and negative 6 and negative 1 give me my negative 7, so that works. And so once you get used to that pattern, that's an actually fairly quick process when the numbers are nice and small, like this, right? But if you don't remember that stuff, then you run into the t-chart, right? So the t-chart says that it has to multiply together to give you 6 and add together to give you negative 7, which turns out to be negative 6 and negative 1. And so you get 2x squared minus 6x minus x plus 3. Group, put your plus sign back in the middle. Factor out a 2x here, leaving me with x minus 3. Factor out a negative 1, leaving me with x minus 3. And then I can factor out my x minus 3's, leaving me with 2x minus 1. Does that make sense? Yes, ma'am.
Did you get the 6 from multiplying the 2 and the 3?
Yeah, it's always a times c.
And you never multiply a times b?
No, not in this scenario in any way, shape, or form. So, cool? All right, so here we are with my denominators. Okay, so I've got a denominator who has a 6 and an x minus 3. Does the other side have a number? Yes or no? Yes. Is it the same number? No. What has to happen to the other side? Multiply by 3. So I know that I'm going to take this fraction and multiply top and bottom by at least a 3, right? In order to get the 6. Now this one has an x minus 3, right? So I've got an x minus 3 here. Do I have an x minus 3 on the other side?
Yes.
Yes, I do. It's right there. Now the other side has the 2x minus 1. Does the first side have a 2x minus 1? So what do I need to do? Multiply by 2x minus 1. And so I'm going to be multiplying top and bottom here by 2x minus 1. Okay. So far, so good? Do you have a question? Do I need to clear something up? Yeah.
Oh no.
Okay.
I was just doing that.
Okay. So, careful. It can be dangerous. All right. So now we need to multiply, and so I am going to use this negative right there and this 3 together. I'm going to turn this into addition. Eventually, you're going to have to distribute that negative anyway, so I like to do it now rather than later. Okay? So when I do the multiplication on the left hand or on the right hand side, I'm going to be multiplying by a negative 3, and I'm going to be writing a plus sign in the middle instead of a minus sign. Does that make sense? Okay, so here we go. We have a 10x, sorry, let's try that again. 10x minus 5 over, and I have a 6 and a 2x minus 1 and an x minus 3. And then I'm going to add, now I'm going to multiply by that negative 3, negative 3x plus 3, and 6, and then 2x minus 1 and x minus 3. So far, so good? Now we combine like terms. And remember, this only happens on the top. It doesn't happen on the bottom. So combining like terms will give me a positive 7x, a minus 2, and then my denominator is 6 times 2x minus 1 and x minus 3. Always check to see if you can simplify. You can't on this one, and so that's my final answer. I'm done. So far, so good? Okay, we have one more problem to deal with. All right. So this problem looks like that. Yeah.
Could you go back up to the other problems?
Yeah. Mm-hmm. My pleasure. All right. What just happened?
Welcome back, problems.
Woo! That was exciting. I don't know what happened there. All right.
They wanted to come with you.
There we go. We're going to do 1 plus 1 over x divided by 1 minus x over y. A complex fraction.
Fun.
Yep. Now, to be honest, this isn't nearly as bad as it looks. Okay? Deal with each piece individually. So we're going to deal with the numerator first. Okay? So I will take my numerator, and I'm going to use blue for my numerator. I'm going to take 1 plus 1 over x, and I'm going to do that part of the problem. What has to happen in order for me to do 1 plus 1 over x? Yeah, Caitlin?
Multiply the left one by x over x.
By x over x, right? Theoretically, I put this over 1, and then we multiply by x over x. Does that make sense? And when I do so, we get x plus 1 over x. Right? Now, I'm going to do the denominator in red. My denominator is 1 minus x over y. And something very similar happens here as well, right? Multiply the left-hand side by? No. By what? No, not xy over xy. Not just y. Y over y. Right? So we put this over 1. I need the denominators to be the same. I don't care about the numerator. Right? I don't care about the numerator. I only care about the denominator. Multiply this by y over y so that my denominators are the same. And that means that my denominator, or my this particular problem becomes y minus x over y. Now, when we have complex fractions, what do? Say again? I heard it, I think. Keep it, change it, flip it. We divide. We keep it, change it, flip it. So we keep the numerator the same. Okay, the first part the same. Right? And so the x plus 1 over x remains the same. We change that big division bar into multiplication. And we take the second one and we flip it. So it becomes y over y minus x. And now we just multiply them together. And when we multiply these together, I get y times x plus 1 over x times y minus x. And there's nothing else that can happen with this one. Cool? This is up on Canvas, but your homework is here.